next and last presentation for today. So this is again a joint presentation by myself and Lubomir, I cannot pronounce your name, sorry, from CalNet. So we're both involved in the GEM project. I'm working for PSNC, the Polish NRN, and Lubo is working for CalNet, the Croatian NRN in Europe. Again, as this morning, I will introduce the use case we're trying to solve and the technical choices that we've made to solve that, and then Lubo will continue and show you an actual demo of the tool that we're currently building. So well, you all know about perfSONAR now, and it's there to spot performance problem, performance issue. But sometimes network engineers are involved in different things and a lot of configuration. Teams is changing a lot. Well, there are many challenges, and sometimes NOC engineers just don't feel comfortable using the CLI to run perfSONAR. And although they have mad dash and regular tests running on, they want to run a new perfSONAR test just right now. So we've been receiving this feature request quite a lot of time in the past to have a graphical user interface to run on-demand tests for perfSONAR. And actually, we had already a tool for that developed in the GEM project a few years back. Unfortunately, we were not able to maintain it back then because it used dated technologies. But we tried to revive that effort, and a bit more than a year ago, during a perfSONAR user meeting in Europe, we asked a few questions about what would be the best, the most interesting feature such a user interface should have. So one of the questions was that if you had access to a list of measurement points, which one would be the most interesting for you to run a new perfSONAR on-demand test? And a majority of users said that from an existing mad dash or psconfig setup, being able to run an on-demand test between the hosts that are involved in a grid would be interesting. Another question we ask is, what are the test parameters that would be interesting for you to have in this graphical interface? And quite unsurprisingly, users said the same parameters that are available on the CLI. So from there, and from other questions and our experience in the past with the PSUI, we draw two main use cases. The first is from a mad dash grid to be able to trigger an on-demand test, and a second one that's actually a generalization of that would be to be from any perfSONAR node registered to the global lookup service, trigger an on-demand test as well. This second use case is a bit more ambitious, so we decided to start with the first one. And maybe you remember my presentation from TechEXtra last year, so the actual real one that we had in New Orleans, where I had this presentation with this slide. So if you had a mad dash grid showing up like this, and you see a performance issue showing up here in a host in Ireland, it would be nice to have a new button available there to allow you to run a new test just right now and not wait until the next scheduled one is available and see the performance. So that's the tool that we are currently building. So what we'll not try to cover here with this tool is to store the results of the measurements. We just want to trigger measurements and display this in a graphical and user-friendly fashion. And maybe in the future, we'd like the possibility to have to compare measurements between different runs or between the on-demand measurement and what has already been stored with the backend, and that's available with Mandash, but we are not there yet. So the tool we developed with that use case and that context in mind resulted in a Python application that's doing direct call to the pScheduler API and using the React JavaScript library to present the results. So that's all components and technologies that are very well understood by the perfSONAR developers. So we hope that building on that, we will be able to maintain this tool better in the future. So now I will hand over to Lyubo for the actual demonstration of the current status of the tool. We cannot hear you, Lyubo. You are still muted.
Sorry, is it better now?
Yeah, we can hear you now.
Okay, thank you, Anton, for the introduction and the background information. My name is Ljubomir Hrbok, but no worries, I know that it is hard to pronounce. And now I will present the demo of the application, which is actually still in the development phase. So let's say we are in some kind of beta version. Although I am talking live, this will be a pre-recorded demo. It is not because of the stability of the application, but for some other reasons, and I think they will be self-explanatory as we proceed through the presentation. A little bit of history. After some period of analyzing the requirements and the proof of concept work that was done by my predecessor, my actual work on this project has begun somewhere at the beginning of this year. And the basic idea was to develop easy-to-use web application capable of starting on-demand measurement via pScheduler API and graphically displaying the results. And as for the technology part, since we were developing a web application, choosing modern JavaScript framework was an obvious choice. So after comparing current JavaScript frameworks and libraries and a little bit of thinking, the choice fell on React. At this moment, we had the perfSONAR mesh, and we had some mockup that was done by Antoine, and the idea to connect our on-demand application with Medesh. But from the moment we have coding our first JavaScript fetch call, we found out that Medesh and pScheduler on our perfSONAR nodes do not come with the HTTP allow origin headers that was needed. And our browsers blocked our fetch requests. So at that moment, we could decide to file a feature request to our colleagues, developers, or to reconfigure Medesh and all the nodes ourselves. But for the couple of reasons, we decided to circumvent the issue by creating a Python proxy to act as a middleman and forward the API request. It is actually a very simple proxy, maybe a couple of hundreds lines of code, but it was proven to be very useful, especially when we got into mathematical calculation issue. JavaScript numbers are normally limited to the max safe integer, which is not suitable for math operation with 64-bit integers, and those are returned by pScheduler as a result of latency measurement with raw packets included. And begin support was added to JavaScript last year, but as we found out, it was still not fully supported, at least in our software setup. And on the other hand, Python handles 64-bit integers with ease. And also, Python allowed us to use the power of NumPy library for other calculation. So at the end, we ended up with this architecture. React JavaScript application running on the client machine communicates with Medesh API and pScheduler API through the Python Flask application running on the G-Unicorn WSGI configured on the Nginx web server. And after this introduction, let's take a look at the user interface. This application is currently hosted on one of the Géant testbed servers but access to it is protected with username and password. Right now, there is no other option except to click on a run measurement link. And this brings us to the form, which is separated in two main areas. So nodes area above offers select boxes, and to choose the source and destination perfSONAR node for the measurement. Basically, measurement will be started through the pScheduler API on the source node. So this application instance is connected to the live Géant PMP monitoring platform service. And because of that, source and destination nodes are provided by fetching the data directly from the Med-Dash API of the PMP service. Just to mention for those who don't know, PMP monitoring platform is a set of small nodes running on the Gigabyte Bricks mini PCs, and they are located throughout Europe, along with a couple of nodes in Africa, as you may have noticed on the drop-down list. So actually, if the list of nodes is long and you cannot find a node by scrolling, you can simply start typing, and filtering works on any part of the machine name. And the toggle button, it allows us to quick swap between source and the destination nodes. Also, since one of the requirements was that application can be integrated with the Med-Dash, specifically crafted URL params will select source node and the test automatically. So this is pre-recorded, so we have to wait a couple of seconds. We can enter a source node and we can enter a test type. Basically, this link should be on the Med-Dash, so user can click on it and automatically selects source node and the test. Bottom area, there are test parameters, and 4 types of tests are possible. So throughput, latency, round trip time, and trace route. Every test has some basic parameters that can be changed, plus some advanced parameters. Not all parameters allowed by pScheduler are implemented. So let's just go to the parameters. Throughput allows us to change IP protocol, UDP protocol, and a number of advanced parameters that can be simply clicked. Then we have a latency measurement. So again, we have IPv4 or IPv6, and the packet count, packet interval, packet timeout, and packet padding. Then there is a round trip time. So packets per tests and a couple of more advanced parameters. And at the end, there is a trace with first hop to report, maximum number of hops, and tools. So under every field, there are a range of values in the description of the fields. And that range is actually obtained from the configuration file of the application. And also it acts as a user input field validator. So you cannot provide value out of specific range. Entering the wrong value automatically disables submit button and marks the field with a red shade. So those are some benefits of the JavaScript application. So let's now start a couple of measurements. Latency measurement is currently the only one that is fully implemented. Other measurement can be started, but we are still working on the representation of the result. So let's select the source and destination node and latency measurement, and let's put the packet count to 500 and click submit. So the overlay pops up and you are presented with a button to cancel the measurement. And after a couple of seconds, we are redirected to the results page with the message that the measurement has been started and that we are waiting for the first run URL. And when the first round has been obtained, we are entering the waiting period until the time the application will try to fetch the results. So now we will use the power of our pre-recorded session to speed the things up and get the graphs and other data. Now we are at only a couple of seconds before the results come. So this is it. Once we got the data, they will be available for the next 48 hours, and we can simply refresh the page or use this link and send it to someone to get the measurement results again. So let's just see what we have here. So the title with the basic measurement data, and under the title there is a link to the perfSONAR node JSON file. We can show it here in another window. So that's the link to the actual result on the perfSONAR node. Then there is a latency diagram for the raw packets. User can hover over the data to see the values for each packet. And there is a median value represented with a red dashed line and the number. Then there is a latency histogram as received from the measurements. And again, you can hover and display the info about each column. Then there is a table below which shows the data calculated from the raw packets, like average latency, delay variation. Those are actually values calculated using the NumPy library. And at the end, there is a list of all packets with their consecutive delays. So let's start another couple of measurements. And this time, we will increase number of packets to 1000. So again, latency and 1000 packets. Okay, just a couple of seconds. So this is it, and we are presented with 128 seconds waiting period. Let's keep that. Okay, and here we have some interesting graph with a large number of packets. And interested measurement is, let's say, there is a big difference between minimum and maximum value. So you can see that in the table.
Lubo, just for a second, if you can scroll up to show that there is a link to the measurement results to the output, since there is on the chat there is a kind of a short discussion. I mean, kind of to point out that we can also show the result of the output from pscheduler. Just scroll up a bit on your screen. I mean, because you have the.
Yeah, but it's not easy to scroll here because
I see. Okay, okay.
No. So if I go back, but actually I can later when I finish this, yes, okay. I can display the live version of the application.
Yes. Okay.
Okay, where we. So this is one of the measurement with 1000 packets, and I have prepared another measurement, and this time we will increase the number of packets once more. So this time we will put 2000 packets, and actually I'm testing the system to the limits because I found out that a lot of times when I start the measurement, if the number of packets is high or something is, you see here, you have to wait about 230 seconds. So let's keep it. And we got this result, measurement failed non-starter. Actually, did you want to see this Ivan. So this is exactly for this type of measurement when we get a non-starter and no times available for this run. This is one of the
Thanks.
results.
Yes, this is exactly what I was looking for. Yeah.
Actually, these are on every small node in the mesh. So on the one that we have chosen to be the source node, it is the one that brings us this result. Okay, and I have only one thing to show. That's the other measurements which are not done yet in the display of the results are not done yet, but the measurement itself works. So we can just start a trace route measurement between two nodes. Let's wait a couple of seconds. And I think I will have once more. So this is the result, and we are presented with a link to the actual results. So once more, you can see the requested. Actually, this is the JSON file from one of these small nodes. This is the one in Carnet. Actually, it's a couple of meters from me here. So basically, this brings us to the end of the presentation. And if you have any questions, I'm sure Antoine and I will do our best to answer them.
All right, well, I think you're all clear in chat. So that actually brings us to the end of the